Have you ever given your plants fertilizer? Have you looked at the bag and figured out what all the numbers mean? All plants require a well-balanced supply of major plant nutrients: nitrogen, phosphorus, potassium, magnesium, sulfur, and calcium. Although magnesium may be added using specialty fertilizers, calcium comes from ground limestone, sometimes used as filler in commercial fertilizer. However, it is not a substitute for additional limestone that may be added to just soil pH. Minor elements are not typically deficient in most soils because they are already present or supplied in the form of impurities found in commercial fertilizers. Certain minor elements such as boron, zinc, and manganese may become toxic if too much is applied. Additional iron may be needed to be applied for some acid-tolerant ornamentals such as azaleas and rhododendron. I'm Dr. DeBusk, and in this video, I'll cover information on fertilizers and their application. Continual attention to soil fertility maximizes crop production. Soil nutrients have four fates. They can be used by the plant, lost by leaching, lost because of runoff, and or tied up in the soil by chemical reactions. Lost nutrients must be replaced to ensure that crops have adequate nutrients for maximal plant growth and development. Nutrients can be added back to the soil in a variety of ways, such as use of a fallow period and use of organic or inorganic fertilizers. Leaving the land uncultivated for a period of several years to rejuvenate naturally is called leaving the land fallow. This only works when land is plentiful and not needed for several years. Typically, soil fertility is increased by applying a fertilizer, which is any organic or inorganic material used to provide the nutrients plants need for normal plant growth and development. Organic fertilizers originate from living organisms that are broken down in the soil by bacteria into inorganic water-soluble forms. Once converted to the inorganic water-soluble forms, they are equally available to the plant whether it originated from organic matter, inorganic fertilizer, or via weathering of rocks. Organic fertilizer can be derived from animal manures, compost, bone meal, dried blood meal, cottonseed meal, soybean meal, and others. Organic fertilizers also include green manure, which is the use of leguminous cover crops for the main purpose of plowing it under to increase soil fertility. This should not be confused with the use of organic waste from cows, poultry, and others as a source of fertilizer. The advantages of using organic fertilizers are: first, they are less caustic than inorganic fertilizers when used at large application rates. Second, nutrients are available more slowly over a longer period of time. Third, nutrients are less likely to be leached from the soil. And fourth, organic fertilizers may act as soil amendments and conditioners. The disadvantages are: first, organic fertilizers are typically low in nitrogen and other nutrients. Second, some forms need to be composted prior to use. Third, nutrients are in an insoluble form before soil microorganisms break them down before they are useful. Fourth, in some cases they produce a bad odor. And fifth, they are more difficult to apply, store, and transport than inorganic fertilizers and others. Because of the difficulties associated with them, organic fertilizers are still only used by homeowners and for specialty crops. Note the bag of worm castings on the video. The analysis is 0.21, 0.06, 0.09. That means that it only has 0.21% nitrogen in it, 0.06% phosphorus, and 0.09% potassium. That's not much. Inorganic fertilizers are materials that are derived from mineral salts. Nitrogen, phosphorus, and potassium are the three major nutrients removed from the soil in large quantities by crop plants. By law, the fertilizer label must indicate the amount of nitrogen, phosphorus, and potassium in the product, and in that order. When only one element is required, specific nutrients can be added. For example, nitrogen is available in ammonium nitrate, ammonium sulfate, or urea, whereas phosphate is available in superphosphates or bone meal, and potassium is available as potassium chloride. There are a number of advantages associated with inorganic fertilizers. Nutrients are soluble and quickly available. There are a wide range of fertilizer formulations available. They're easy to store and apply, plus a variety of other benefits. Some potential disadvantages are over-fertilization when only small amounts are needed. Soluble nutrients in concentrated solution may cause damage to plants, and some nutrients are very soluble and may be lost from the plant's root zone through leaching. A complete fertilizer contains all three primary fertilizer nutrients and may have select micronutrients. For example, a 20-10-20. An incomplete fertilizer lacks one or more of the three primary elements found in a complete fertilizer, such as 20-00, 0-20-0, or 12-0-44. Fertilizers can be obtained as fast release, which means the nutrients are immediately available. These should be used with care because they can cause burning if used improperly. There are also slow or controlled release fertilizers, which means nutrients are available over a long period of time but do not overcome a deficiency quickly. An example of a commonly used slow release fertilizer is Osmocote. There are also fertilizer formulations with herbicide, where the herbicide is 2,4-dichlorophenoxyacetic acid, 2,4-D, which is an auxin compound that selectively kills broadleaf weeds. This photo shows a typical fertilizer label. The fertilizer analysis, which is the proportion of nutrients supplied by a fertilizer formulation, for a complete fertilizer containing 24% nitrogen, 8% phosphate, and 16% potash, it is marketed as a 24-8-16 analysis, or a ratio of 3:1:2. The total active ingredient, which is the percentage of nutrients being applied, is 48%, and the total inert ingredient, which is the carrier or filler ingredients, is 52%. The inert ingredients typically make up the major weight in a bag of fertilizer. The example shown is a soluble fertilizer that is mixed with water first. Fertilizer can come as either a solid granular or liquid, which can be applied in the irrigation water or as a foliar application. Prior to fertilizer application, you should run a soil test to know what amount of fertilizer to apply. Fertilizers can be applied prior to planting if necessary, and then at various time intervals during the growing season based on the subsequent analysis of nutrients found in the soil or plant by testing. The application rates are determined by a variety of factors. To be absolutely sure how much fertilizer to apply, run a soil test before the first application. A soil test not only provides when and what fertilizer to apply for a specific crop, but also, more importantly, when fertilizer is needed. This is very important because over-fertilization is much more serious than under-fertilization, because once nutrients are in the soil, it is very difficult to remove them, and plants are typically injured more by excessive nutrients than from a nutrient deficiency. Factors that influence the amount of fertilizer that needs to be supplied after the first fertilization is cropping practices, soil type, fertilizer concentration, present crop, and plant needs. It is advisable to run a soil test at the end of every growing season to obtain the best results year after year. There are many methods for applying fertilizer. It is important to have a fertilizer in the soil at the proper time and place to ensure maximum absorption by the roots, which is critical for seasonal crops such as flowers and vegetables. Fertilizers can be applied in three ways. The first is dry application, which is applying dry fertilizers to the soil. Dry applications can be made in several different ways. Broadcasting refers to evenly spreading the fertilizer either manually or mechanically on the soil surface. Broadcasting is quick and easy, but fertilizer may be wasted depending on plant spacing. In landscaped areas, broadcast application is typically used to spread fertilizer uniformly over the soil surface. It is important to apply fertilizer during the early spring. By applying fertilizer at this time, nutrients can be used by the plants when they are actively growing. Broadcasting is also very common when applying fertilizers to vegetable gardens. Once the fertilizer is applied uniformly, it should be incorporated into the soil to a depth of 3 to 4 inches. This method works best for shallow-rooted crops such as beets, lettuce, peas, and others. Top dressing is the placement of fertilizer uniformly around the stem of the plant and is used to apply readily available nitrogen fertilizer to promote leaf growth. Urea, nitrate of soda, and ammonium sulfate are water-soluble and are commonly applied using this method. Top dressing is very effective on sandy soils and for crops such as leaf lettuce, spinach, and other leafy crops. However, caution should be made not to get any fertilizer on the leaves because burning can occur. Side dressing is when fertilizer is placed in bands along both sides of a row of plants about 4 to 8 inches away from plants. This method is effective on sandy soils where material has a chance to leach into the plant's root zone. Side dressing is not recommended if fertilizer was applied as bands at planting time. For band applications, fertilizer is placed 2 to 3 inches on one side of the seed. Note that if a fertilizer is placed too close to the seed, it can cause damage. Band application of fertilizers work well when small amounts of fertilizer need to be applied and can also be used as a supplement to broadcast fertilization. The second way to apply fertilizers is through liquid application, which is the application of water-soluble forms of fertilizers to either the soil or leaves. Starter solutions are water-soluble materials high in phosphorus. They work best when no fertilizer has been applied to the row prior to planting. After planting, the starter solution should be applied to the soil around the roots of recently planted transplants. And then the moist area around the plant should be covered with dry soil in order to avoid soil crusting. When fertilizer is applied to the soil through the irrigation system, this method of application is referred to as fertigation. A third way to apply fertilizer is by gas application, such as applying nitrogen in the form of ammonia gas. A combination of the above-mentioned methods of fertilization could be used to obtain the best results for any situation. For long-season crops such as tomatoes, peppers, and others, incorporate 2/3 of the needed fertilizer and side dress the remainder during the growing season. Whereas for short-season crops such as lettuce, half of the fertilizer may be incorporated prior to planting and the remainder broadcasted and worked into the upper 3 inches of the soil later in the season. Organic matter is very important for good quality plant growth. There are a number of benefits of organic matter in the soil, including increased water holding capacity, provide pore space, which enhances aeration that is critical for good plant growth, prevent small particles of clay from producing a solid mass, thereby enhancing root growth, regulate the soil temperature, release small amounts of nitrogen and other nutrients as it decays, increase the cation exchange capacity, CEC, which is a measurement of the soil's ability to hold nutrients, and promote the growth of microorganisms, which in turn helps to condition the soil. Organic matter can be added to the soil in a variety of ways, including, but not limited to, manure, compost, peat moss, and others. Alternatively, organic matter can be added by planting cover crops known as green manure, which is also an effective way to improve soil conditions. Organic matter seldom provides a balanced source of plant nutrients because most are low in phosphorus. Decaying straw, leaves, grass clippings, and sawdust could initially deplete the soil of available nitrogen. Regular application of organic matter in a complete fertilizer is key to having vigorous growth of plants. For ornamental plants and turf areas, incorporating adequate organic matter is even more critical because there is only one opportunity to incorporate it into the soil before planting or seeding. Once permanent crops are established, it is difficult to incorporate organic matter into the soil without injuring plant roots. An inexpensive method to obtain organic matter by the commercial grower and the home gardener is to compost. Compost not only helps improve soils, but it is also a good way to dispose of plant residues and at the same time is good for the environment. Prior to starting a compost pile, it is important to check your local ordinances to make sure that composting is permitted in your community and, if permitted, the specific regulations involved. A compost pile can be made from any form of disease-free plant material such as leaves from weed and crop plants, grass clippings, sawdust, and a variety of others that decay rapidly. Always use disease- and insect-free plant material to reduce the risk of spreading these problems to the garden with the compost. Meats or dairy products are never included in the compost pile because they will attract animals. A compost pile should be constructed in layers with a final height not exceeding 5 feet. The initial layer should be firmly packed organic material approximately 4 to 5 feet wide and 8 inches deep. Next, add 1 pint of complete fertilizer, 5-10-5, a quarter cup of superphosphate, and a quarter cup of limestone per square yard of compost. Add a thin layer of good garden soil to the layer of organic material and fertilizer. The soil provides the microorganisms necessary to break down and decay the organic layer, whereas the fertilizer and limestone aid the microorganisms and improve the nutritional quality of the final composted product. Enough water is added to moisten the entire layer, making sure not to add an excessive amount because this will reduce the decomposition rate. After the pile is started, more layers can be added to get the desired height. During heavy rainfalls, make sure to cover the pile because excessive rainfall will cause leaching of nutrients. After 2 months, turn over the pile to incorporate air, which aids in the decomposition rate. And after 4 to 6 months, the process should be complete enough to use the compost. The compost is spread on a designated area and then incorporated in the soil, as would be done with animal manures. An application of 50 to 100 pounds per 100 square feet is advisable. In a garden plot, compost may be incorporated at planting or used as mulch and turned under before the next growing season. In conclusion, in this video you learned what different fertilizer formulations are available and about the basic fertilizer nomenclature found on the bag. You learned commonly used methods of fertilizer application, the proper time of fertilizer application, and ways to increase the organic matter in the soil.